Okay, so here we are with a tree diagram, and all of these add up to 1.0, aka 100%. And I just asked the students about this. I said, if I talked to one of you and found out that these were the things that were possible for you this summer, that you might have gone to summer camp or take a road trip at summer camp, you could have done the glider or the horse, and we had all these probabilities, then the question is, if I knew because you told me later, yeah, I got to go to summer camp, now what's the probability that you rode the horse? Given summer camp, what's the probability of horse? Would you please talk to the kid next to you and argue it out, see what you think, see what they think.
Where did you get out of C, bro? Because it's a 30% chance to go to the summer.
But it's a given that you're going to summer.
Yeah, we already know you're going to the summer camp, Charles. So it's 80%.
All right. There is two ways to do it, but the answer is 80% chance. So raise your hand if you knew that it was 80% chance. Okay, good. Now, I think, though, a lot of you did it wrong and got 80. I think a lot of you just looked at this and went, that's 80, so it's 80. Okay, but I want to make sure on the more complicated questions that you get this. As soon as you went the summer camp route, then do you get all of a sudden only these things were possible? So it's what you wanted out of what was possible. So what you wanted was 0.24 out of what was possible, which was 0.24 plus 0.06. I'm just trying to get you to look at it a different way, because it's still going to be 0.24 out of what does this add up to? 0.30, which comes out to 0.8. But it's what you want over what was possible. And see, if you just grab this because you happen to see it, you're not understanding what it is. What it is what you want is that 0.24, but it's out of 0.30. It's what you want out of what's possible. All right, let me give you one more question that's about this chart since we took the time to make it. How about this? It's going to be trickier. Given you did not ride the ATV, I asked you, did you get a chance to ride the ATV this summer? And you say, nope. What's the probability of horse? Given not ATV, what's the probability of horse? Hint, it's a higher probability now. Remember what I just told you? It's what you want, but it's divided by what was possible. And as soon as I gave you a given, it wasn't out of 100 anymore. Givens changed what it's out of. All right. So as soon as I said you did not ride the ATV, then this was out, and these were the only things possible. So those are what's possible. They go on the bottom. 0.06 plus 0.24 plus 0.42, and that adds up to 0.72 on the bottom. And what I wanted was the horse, which was this one. So 0.24. 0.24 over 0.72. See, that one you weren't going to find anywhere just sitting on the chart. You had to know how to do what's possible and put it on the bottom. And what you want, which was the horse, which was the 0.24. So let me get a final answer on that. What is 0.24 divided by 0.72? Point three repeating. Raise your hand if you had that one right. Nice. About 33%. Okay. So, do you feel like you understand it? All right. Now, there's a little bit more to it, but not a lot more to it. Let's do the same chart one last time. What's the probability that you're going to do the horse or the ATV? You got to know what to do with ors. What's the probability you're going to do the horse or the ATV? Here's horse. Here's ATV. Should have had 0.52. Raise your hand if you had that one right. Okay, awesome. Or means add. And they're big answers. Like, what if I said, what's the probability you'll ride the horse or the ATV or go to Six Flags? Well, now all of a sudden it's almost everything. It just keeps getting bigger and bigger and bigger. So ors are big answers. And it's counterintuitive. It is. You'll find that the questions will confuse you because it'll be like, what's the probability of this or this or this? And it seems like it's going to be small, but it's in fact big. Ors are big answers and ands are small. See, like what if I said, what's the probability you did the horse and the ATV? It's actually 0. Because if you went to horse camp, you didn't go on the road trip. These are called mutually exclusive events. Obviously, in the real world, you could actually do both, and then it's even more complicated chart. Okay, good. I think we should actually get into your homework. I think you're ready. I am having you skip problems 2 and 5 just because it feels like it's too long. And I think that'll make it very doable. You got to draw these charts, which are kind of intense. I'd rather have you do just a few charts very well. Like, draw them nice and neatly. Find a worksheet for today. And cross out problems 2 and 5. Now, problem number 1's about cards. They do spell out for you all the stuff you have to know about the cards. But some things they don't actually spell out, but I'll say to you is things like hearts, for example. Each one of the suits, there's 4 suits: clubs, spades, hearts, and diamonds. And so there's a 1 in 4 chance of a heart in the first place. But you might want to do it as when it's hearts, which I think the first question's about hearts, isn't it? Yes. Okay. You might want to do it with how many hearts there are total in the deck. And there are 13 hearts out of 52 hearts. Sorry, cards. 13 hearts out of 52 cards. That'll help a little bit on this problem. But I want to remind you of something. If the first time you go and try to get a heart, you have this chance, what if you take a card out and it's not a heart? Then what's your chances if it's not a heart? 13 out of 51. Very good. But what if you did actually get a heart the first time? Then it'll be 12 out of 51. So how do you organize all that? With a table. Or a tree, actually, is what we call them. With a tree. So let's make the tree. And I think some people are going to go a really complicated tree. I used to. Because there's clubs and spades and hearts and diamonds. But actually, couldn't you just make it a 2-part tree when you first draw out of the deck? It's either hearts or not. You see what I mean? You could have done hearts and spades and clubs and diamonds and had 4 different things, 4 different branches, but this is way easier. Heart chance, 0.25. I just know that one by heart. Could be thought of as 13 out of 52. The not hearts, well, that must be 75 because these always add up to 100%. See how easy that is? But the next one is definitely more complicated. Because now, hearts is not a 25% chance because they said in the problem that you take out the first card and you don't put it back. So now my hearts probability is there's not 13 in there anymore. Because if I went on down this road right here, if I went that way, then now there's only 12 hearts left. And there isn't 52 cards anymore. There's 51. Get how I did that? And for the not heart, if I went this way, the first card was a heart. So there's still only 12. No, wait. I want not hearts. What is that? 30-something. Anybody got it?
39.
39, very good. There's 39 not hearts in the deck. But there isn't 52 cards anymore. There's 51. That's what makes this dependent. That's one of the answers you're going to have to write down. It's dependent because it depends. Did you get a heart or not? Do you get how it depends? Because if you got a heart, then it's this probability. If you didn't get a heart, the first card, then it's that probability. So if it depends on what you got before, it's dependent. Well, let's say it was about flipping a coin, and I get a heads. Now I'm flipping it again. Does it depend on what I got the first time? No, that's called independent. But if it's something like cards where you've got a bunch of them and you take one out and it changes how many there are, then it's dependent. Okay? All right. That's how you tell independent from dependent. All right. Now from here, if you need help, you need to come up and ask, or you can talk to that kid next to you. And that's all I've got for you for today.